So in order to work with loads of data, we could just rely on NumPy, for example. But luckily in Python, we have one package, or there's probably many, but the one that I want to present today is called Pandas. So Pandas is a package that is a quite widely used package specifically for data analysis in Python. And so the one-sentence summary is Pandas is a high-performance, easy-to-use data structures and data analysis tool. So let's see what it's used, what you can use it for. So essentially, think of Pandas whenever you have to work with huge amounts of data sets, such as climate data. And if you want to work with these data sets, but also if you want to automate processes to work with these data sets. So for instance, maybe the data set doesn't come in one file, but it's distributed across multiple sources, and you want to kind of merge all these data sets together to perform a unified analysis on it. So Pandas provides us with some options to merge data. Another really important aspect when you work with real data is to clean up data. So essentially, every real data will have some gaps in between. Maybe you have some time series, and just the device just stopped working after a week, and you have 1 week maybe just where there's no data, and you need to maybe do some interpolation or extrapolation, or just remove this noisy data and so on. Maybe there's some inconsistency in the formatting that you need to fix, and all these things. And then Pandas provides us with functions to import and export data. So this is really important. Importing, of course, we need to get the data somewhere into Pandas, but also exporting. Maybe we want to do some post-processing analysis using Excel or another programs. I will also show you Pandas can actually be quite useful to generate LaTeX tables. So this might be useful if you write your master thesis and you want to automatically generate the tables from maybe doing some performance analysis or some tests. And you can have a Pandas script that just generates the tables, and you can just use them in your master thesis, instead of writing LaTeX tables by hand, which is really annoying. And then finally, once you're in the Python land, right, you can make use of all the other Python packages out there. So for example, maybe you want to import the data using Pandas, do some pre-processing on it, and then convert it to a NumPy array, and then do some numerical operations using NumPy. Or something that I will show you also as part of this lecture, you can of course use it in combination with Matplotlib to do plotting of the data. So if you want to know more about Pandas, there's, as always, loads of information online. There's the official Pandas documentation that is really well written. There's a Pandas cookbook, which is a kind of an introductory material for Pandas, which is also really nice. And then, of course, you find plenty of books. I think one of the most common one, or the highest rated one, is this Python for Data Analysis, I don't think, I tried to download it yesterday for the UIO VPN, but that didn't work. So I think if you have to borrow it from the library or buy it. So installation, if you have the Anaconda package, then it's already installed. If you have Miniconda, then you install it like any other package, conda install pandas. And then if you have any other Python distribution, you type in pip install pandas. And then I typically like adding this -- user flag, which means that the package is installed locally for your user. So you don't actually change the system-wide installation. You just have an installation that is part of your user. Okay, let's have some first steps. So these settings are actually just relevant for, most of these are just relevant for my IPython notebook installation. So I just say here that I want to have the plots as part of the IPython notebook. And this is where I actually load the Pandas package. I use this shortcut PD because we will use it a lot. I also need matplotlib, so I load it in straight away. And then these two settings here, they essentially, I just use them to make plots prettier. So matplotlibs can be quite ugly by default. So I just changed the style here to make it a bit more pleasing to look at. Okay, so now we've loaded Pandas. So now, before we can start, we need some interesting data sources, right? We need some data to work with. Now, I mean, nowadays there's huge amounts of data out there. I just have a collection of some that might be interesting, in particular in Norway, if you want to work with data. And so one is the SSB, the Norsk Statistisk Sentralbyrå. And they actually have a really nice website where you can download any types of statistics in Norway. So if you want to do data analysis on the employment rates in Norway, on immigration rates, the housing market, or whatever, you can go to SSB, and in most cases you can just download the data, and it's typically in this comma-separated format, and then you can import it into Pandas and start working with it. Then there's Fin. So this Fin API. It used to be open. Unfortunately, I just checked it yesterday, and unfortunately they closed it. So I think now you have to have a business account or something like that to actually make use of it. So that's a bit unfortunate. Then there's Router API. So that's actually a lot of fun if you want to build a side project. So from the Router API, you get live departure information about the T-banes and the buses, and you can also do traveling plans. So for example, a friend of mine has built a little screen that you can so this is based on a Raspberry Pi that runs Python, and it essentially grabs the data from the Router API and displays when the next T-bane leaves to the city center, in this case from Bøhler. So it's quite useful if you don't want to miss the T-bane. So what else is there? There's Ur data, if you want to work with weather data. There's the Oslo Bike API. So this gives you live usage data about the city cycles, bicycles, and also statistics on how it has been used over the last years. And we will actually use this data for this lecture. So we will do some data analysis on the Oslo bike usage. And then you get financial and economic data, and almost every smart device nowadays that you can buy will provide you with some data that you can potentially use for your own project. Okay, so now we've decided on which data we want to use. So we need to learn how to load in this data. And in Pandas, these functions where you load in data, they all start with read underscore. So I can use this IPython syntax here, star, to just have a placeholder and question mark to get a list. And so here you see all functions that start with read underscore and that are available as part of Pandas. And you'll see there's loads and loads of options that you can choose from. So you can read data from a clipboard, from comma-separated files, from Excel, from HTML, from JSON, and so on and so forth. So here we have many different options. And so in particular, the one that we will be using is this read CSV. So if you look at the documentation here, you see you have the most important part is that we read comma-separate files into a data frame. And then you'll see you have loads and loads of options because CSV files are typically not very consistent, and so you might have to adapt it for your needs. Okay, so to make this a bit more interesting, I thought it might be nice to work with some real data. So I downloaded the monthly usage data from the Oslo bicycle, from the Oslo bicycle offer. And so they have this webpage, developers.oslobicycle.no/data, where you can essentially download, for each month, you can download a CSV files that contain all the trips that have been performed during that month. So for example, here I've downloaded 3. So it's is it August, September, and October 2016? So it's always this October, August, and September here. So they're about 14 to 21 megabyte containing all the trips. So let's look at how these files look like. So I'm using this bash command head. So this command just shows the first few lines of a file. So I just use head, and then I use the file name. So this is now this file name of the statistics in October 2016. So 1st of October 2016 to 31st of October 16. So now this is the first 10 lines of this file, and you can see the first line contains the headers, and so you see this file contains the start station, the start time, the end station, and the end time. And then we have loads of rows, and each row corresponds to one trip that was performed with the Oslo, especially with the Oslo cycles. So in particular, you'll see the stations. So the way you have to read this is it's comma separated. So the first number here specifies the station ID, is the station ID where the trip has started, right? And then this is the time when it has started, and then this is where the bike has been topped off, again as a station ID. And then there's again the timestamp when the trip has stopped. So if we read this first trip, there has been someone who started driving it on the 1st of October at 8 seconds past 6. So I think the bike stations actually, they start opening at 6 o'clock. So someone was really ready at 8 seconds later after it opened to go cycling. And then he started in station 283, and then he cycled to 238 in 9 minutes and a few seconds. So his trip was about 9 minutes long, and then he topped it off. And so you go, right? So you can read, so the next trip was at 6 o'clock and 41 seconds, and so on. So this is the data that we work with. So now, in order to read this in, this is a comma-separated file. So we use the function pandas read underscore CSV. And as an argument, we just provide the file name. And I also provided an optional argument, the separator. So I specify how are the columns separated in that file. And in this case, it's a comma. So sometimes it can be a semicolon and so on. But here we have a comma, as you can see in our file. Okay, so if we execute this, so now we have this object bike stats. And if you look at its type, it's a Pandas core frame data frame. So these data frames, they're essentially tables. They're two-dimensional tabular data structures with labeled axes. So we can print them out. This is what it looks like after reading in. So this is now the Pandas object printed out. And so you can see it's essentially the same information as we had before, just in a prettier format. Right? So we still have the start station, the start time, the end station, and the end time. And now just as a Pandas object. And so also Pandas added a index for us. So this is now, each row has now a unique number that we can use to identify a trip with. So now there's loads of these. Pandas automatically stops it, but we can see in total, so this was the October data, I think. In total, there has been 242,758 trips during that period. So it's a bit annoying to, whenever we print out this Pandas table, that we get 240,000 rows. So often it's very useful to only show the first 5, for example, or the first few items. And for that, you can use the head function. So when you use a data table and you just call head, then you basically get a reduced version of the data table that just contains the first 5 items by default. So then you get the first 5, but you can also type in a number here. Let's say you're only interested in the first 3. Then you just specify the number here. But it's essentially, it's just a way now to visualize it pretty. Okay, so next we want to select some columns of interest. So the way you do that is with index notation, very similar to what we know from lists. So use the data table name and then the square brackets, and then you provide the column in which you're interested in. So in this case, if I'm only interested in the start time, and then I can reduce it to the first few entries. And this is what you get out then. So this is now only the start time shown. So the same thing works if you have multiple columns. There you just have to be careful that you use 2. You need to have a nested list as an index. So just be aware that you use 2 brackets here. But essentially it works the same way. So now I only show the start and the end time for each trip. Okay, so one thing that you need to be aware of is when you load in data, Pandas tries to be clever and determine automatically which data types each column has. So we can look at these data types by typing in bikestats.dtypes, and it will tell us for each column which data type it has identified it with. So the start station, it decided to use an int64, which makes sense because the start station, they were always integers. The start time was determined to be an object, which is probably not what we want. And then the end station was determined to be a float 64, which is also a bit strange. We would expect it maybe to have an integer there also. And then the end time was an object as well. So the first thing that we need to fix is that the dates or the times weren't passed correctly. So we need to tell Pandas about the fact that these are really dates, and so there are 2 ways essentially. You can specify which date format you're using manually, which can be a bit annoying, or you can tell Pandas to put a little bit. You can tell Pandas that this is a date column, and that it should try out various different options to try and identify which date format you're using automatically. And so this takes a bit of time because it needs to try out various different options on which date format you might be using, but at least then you don't have to sit there and program it manually. And it's exactly what I'm doing here. So in this line here, I'm reading and I'm calling this read CSV function again with the file name and the separator. But now I also use this parse dates function argument, and I specify the columns. I specify the columns that I think should be, which I know are dates, and then Pandas will try and parse them properly. So if you do that, so now loading in the data takes much longer, as you can see in the star. So it's still running, and that's because it now needs to. It takes longer to parse these dates. But now if we print out the results again, you'll already see that it has. This is now a different format because Pandas has recognized the dates correctly. And in fact, if we manually check the dates, the D type of the start time column here, so I call bikestats types, extract the start time column, and check that the D type is equal to date time 64. And then I get value 2 out here. So indeed now I can, or if I just do this, or in fact if I just do this. No, that didn't work. Anyways. So this now identified the dates correctly. So the last thing that was a bit strange was that that the end station here was detected to be a float 64 rather than an integer. Yeah.
But
Yeah, so that's a good point. So yeah, that's a really good point. So I think what's going on here is that it converted it to UTC format. So now suddenly, because, yeah, so I guess now what we could do is we could specify in which time zone we are in, and then it would print it again at 6 o'clock. Yeah, but that's a good point. So the next thing is this end station float 64. So why hasn't it detected it to be an integer? Right? If you look at the data ahead again, the end station here, these are just integers. And so the reason, yeah. Sorry. No, so that's right. So Pandas converted them to floats. Even though if you look at the raw data, here, if you look at this column down here, right, they are integers, but Pandas converted them to floats. And so the reason is, so I was struck by this when I started loading in the data, and I thought, well, that doesn't really make sense. And it turns out that sometimes people just don't return their bikes. And then a bike trip doesn't have a stop station. And in this case, you just have nan, or not a number value. Right? And so with integers, the integer data type doesn't have a not a number, while the floating point data type does have a not a number. So essentially what Pandas did is it realized, okay, some of my rows has a not a number value, and therefore I can't use integer, and I fall back to floats. So that's what's going on. And so these are the typical things that you need to deal with when you work with real data, right? You think everything is clean, and then suddenly data is missing, or data has unexpected values. So, okay, we understand it, and we can't do much about it, so we just keep it as a floating point value for now. Okay. So now we can start, now we've got the data loaded in, so now we can start plotting the data. And conveniently, plotting is very simple, so all you need to do is you extract the data that you want to plot. So let's say we want to plot the start station. Then for simplicity, I don't want to plot the 240,000 data points, so I just reduce it to the first 10, and then I call plot. And then this is what I get. So I get a nice plot with, on the x-axis, I now just have it's just enumerated, starting from 0 to 10 for the 10 data points. And then on the y-axis, you have the station ID. Right? So you can see, so it doesn't really make sense to have a line plot here, right? So, but maybe we want to plot 100, and then it looks a bit more spiky. So we can also plot multiple. We can also plot multiple columns. So it works exactly the same way. Just now I extract for example, the start station and the end station, and then I plot it, and then you have multiple lines, of course, and conveniently, Pandas already immediately uses some labels on the top right so that we can see which line corresponds to which column. So now it would be nice. So one thing that we can do now to improve this plot is to use at the moment, the x-axis is just enumerated. But it would be useful to at least have the date. So each data point here, right, each point on in our plot here corresponds to one trip. And so one trip starts at a specific date and time. So it would be useful to plot this date on the x-axis. So the way you do that, we use the same plot command, but now we say, I want to have, on the x-axis, I want to have the start time column. This is what I specify here with x equals start time. And then on the y-axis, I want to plot the columns start station and end station. And then, so this is what you get if you plot 1,000 trips. And now, as you can see, on the x-axis, we now have the time plotted, which So then it becomes a bit more useful, and we can actually start seeing some patterns here. Right? So on the left, this is now 4 o'clock, which we, in UTC time, so really it's 6 o'clock for us. And so you can see it's a bit sparser here on the left side. And then if we start converging to 8 o'clock, or actually start maybe at around 7 o'clock, which is 9 o'clock our time, it tends to be a lot busier. So our first conclusion by reading this data is that people don't drive so much at 6 o'clock, but more at 9 o'clock in the morning. Let's see what happens if we do even more. So yeah, so it tends to become a lot more busy during the day. Oh yeah, there we go. So that's interesting, right? So it's really busy, and then suddenly there's nothing, and that's where the station is closed, right? So there's obviously no trips during that period. Let's try some more. 20,000? Let's try 40. Yeah. That's some maybe not so informative anymore, but there's clearly breaks in between. Okay, so if you want to know more about plotting, again, use the documentation. And so maybe the most interesting thing is, so there's again loads of options, and you can change the colors and the limits and so on and legends. But maybe one thing that is immediately useful is this kind. And with kind you specify which type of plot you want to have. So the default is a line plot, but maybe it's also useful to have a different type of plot. For example, a bar plot. And so essentially you just change kind equals, set it to bar, and now you get a bar plot. And this makes a lot more sense now, because each bar now corresponds exactly to one trip, and you see the start station and the end station plotted for each trip. Right? It doesn't really make sense to have two plots connected, so a line plot isn't so sensible in this case. Okay. Yeah, and then another one that is quite useful is this histogram. And so a histogram plot converts. It's basically it counts how often the Y label occurs in your data. So the Y-axis in this case is the start station. And so in this plot we can see on the X-axis we have the station IDs. And on the Y-axis we have how often this ID occurred in the data. So from this histogram table you can start seeing which stations are more busy or have been used more than other stations. Now, unfortunately, this plot starts lumping together multiple station IDs. So we can't really figure out yet which station exactly is the most busiest one. But at least we get an idea. At least we see, so I guess what we can see here is there's some variation between the different stations. Right, so now we've done some, we've loaded in the data, we've cleaned it up a little bit, we've extracted the parts that we're interested in. So sometimes it would be useful to just save it out again. And so there's different ways on how you can save it. So one common way is maybe you want to do some more plotting with Excel, or just share your data with someone else. So the commands to save data or to convert data into different format is they all start with to underscore. So there's read underscore to read in, and then to underscore to output it again. And so again, you have various different formats. One common one is this to CSV, and then the output is a comma-separated file. In fact, you get a string. You get a string out of that, and then it's your responsibility to write it out to a file. And then, so as I mentioned before, one thing that is quite useful is to use this to LaTeX command. And so that essentially converts your data table into a LaTeX table that you then can copy and paste into your LaTeX file and compile. So it looks a bit messy here, but if you actually write it out, and of course if you compile it, then it will look nice. So as I said, these functions, they return strings. So if you want to write it actually into a file, then you use the standard Python commands to do that. So one thing that you maybe haven't seen yet, so one thing is that you can just write f equals open. So that I've showed you this before in the first lectures. F equals open file name, and then f dot write. Then you write all the different lines, and then you write f dot close to close up the file again. The problem is, so I can write it up here. F equals something like this. So this is kind of the classical way. And then f dot close. So this is one way how you can implement it. But a better alternative is actually to use the with statement. And so the reason why this is better is, so with creates a context in which commands are being executed. And the nice thing about the with statement is that you don't have to worry about closing the file again. The file is being closed automatically. So by using with open as file, then this file object here is only available in the indented lines of the if of this with statement. And as soon as you're outside again, a file is being written out to file and then removed again. So here, file is a scoped object, and you don't have to worry about closing it and writing it. Yeah, so it's a bit of a safer option, just as a trick. Okay, a bit more about selecting data. So I've already shown you how we can select columns, but we can also select rows. So for selecting rows, we use indexing, slice indexing. And so it's a bit tricky because this is actually also being done using the square bracket. So it's a bit confusing. So we use square brackets both for columns and for rows. The trick here is that if you use integers as in the slicing index, then Pandas will select the rows, and if you use the names of the columns, then it will select the columns. But so here, for example, we restrict the data from data point 5 with index 5 all the way up to index 14. But we can also combine the two. So now, if you wanted to select one column and then only certain rows of that column, the way you do that is you concatenate the square brackets. So you first use the column indexing to restrict the column that you're interested in, and then you use the row slicing to slice the rows that you're interested in. Okay, so let's do our first data analysis. Let's find out what are the top 10 bike stations that are in Oslo. So what is our, how do we do that? So for each bike station, for every time a bike station is used, we will find one row in the data where with this bike station's IDs is in the start station column. So in other words, in order to find out how often a bike station was used in total, we need to count how often that station ID occurs in the start station column. And once we've counted them all up, we just need to sort this counter from high to low to figure out what are the most used bike stations. Essentially, if that number is 0, right, then this bike station has never been used. If that number is really, really high, then this bike station has been used loads. And so this is exactly what the function value counts does. So value counts, we select one column, in this case the start station column, and then we call value counts. And what that returns us, it returns us for each station, for each start station, it returns us how often that start station occurred in the data. So in particular, the station 233 was used 7,832 times. And then the next one was used 6,713 times, and so on. So I restricted it to the top 10 here. So this is how you can get the usage of specific columns. So now we can plot this. So I again extract the start station. I count the values. I limit it to the first 100 ones, and I plot it as a bar. And now you can see all the different stations and how often they've been used in October. Right? So you can see there's a few stations. The top 3 were used extensively, and then it drops off very quickly, and it after that it kind of flattens off. And there's a lot of bike stations that have been used in a fair amount, but the first one has been used almost twice the amount as the top number 4. Okay, so the next thing, so at the moment we've always been working with this abstract station ID, so that's a bit boring. Ideally we would like to get some more information about the stations, right? So each station has a name, it has a location, it has GPS coordinates, and so on and so forth. So we need to start working with more data tables to get more meaningful outputs. And so luckily, the Bicycle, or the Oslo Bicycle, they also provide this file stations.json. And that I downloaded that, and it contains exactly the information that we want. So I just used a little tool here to print this data in a nicer format. And so if you read this carefully, so clearly we get a list of, this file contains a list of stations. So this is just a normal text file. This file contains a list of stations, and so for each station we get the ID, we get information about if it's in service or not, we get a title, so that seems to contain the location where it's placed. We get some additional information about where exactly it is, so Mellom Nürnberggatter and Uhrteggatter. We get the number of logs, so that's quite interesting, and we get the exact location, or the location of the center of that bike station in GPS coordinates. Right, and so that's the first station, and then here you get the next station and so on. So we get a list of all the stations with all the metadata that we might be interested in. So if you look at this, it's a .json file. So the obvious thing, if you want to read this in, is to use the read JSON function in Pandas. Now I tried this, unfortunately it didn't work. So it's because actually Pandas, this read JSON function, expects the data to be in a very specific format, which is not the case here. So I had to do something else. I used the JSON module. So there's a JSON module in Python, and you can use that to read in the data. So I used json.load and then provided the file name. So and then if you do that, you see now I have exactly the same data. It's exactly the same data, but just now as a Python object. And so and so if you look at this data more carefully, there was this. It's actually a nested list, and so it's the station thing that contains all the information. So I just extract only the stations part of it. No, it's not so interesting, but the end effect is that now the station JSON object now contains a list with all the stations' informations. It's a list of stations, and for each station we have all the information that we need as a dictionary. So now we have that as a JSON object, and so now we use something. So this is a bit tricky, but there's something called pd.io.json.json normalize, and this specific function allows you to load in JSON data. And once you've done this, we are back in the game. So now we have, the result is now a Pandas, a data frame that has exactly the same structures we had it before, just with loads more columns now. So now the each row here corresponds to one station. And you see we have loads of different columns, including the ID, which is important. If it's in service, the number of logs, and so on and so forth. And the GPS coordinates, which is quite useful. So that's good. So we've got the data in now. Yeah, it's 11 o'clock. So let's have a break and let's start again at 1:15.